just running it off of their computer.
They're running it off of their computer. They couldn't get this thing going.
Okay, so we don't have a confidence monitor or anything.
We don't have a what?
We don't have a confidence monitor or anything for people to see when they're talking. So,
No.
Do you have the presentations on yours?
Yeah.
Okay, so maybe I'm just trying to think if that would still be, if it would be useful for them to have the two things up and running.
We could have them here and have it on, Mike.
Yeah, they just have to understand that they got to use that to advance. Otherwise, they're going to be seeing stuff the audience won't see.
Yeah.
That's weird. Check.
Ladies and gentlemen, we'll get started here in a few minutes. We've been a little bit delayed as we're getting ready to do the streaming, so bear with us and we'll be ready to go in a few minutes.
Good afternoon. Good afternoon, and welcome to the first session of AAPT 2018. And I thought we were going to be good and ready, starting at 1:15, getting organized, and we had some technical issues, and here we are. It's already past 2. So I appreciate your patience as we get started. My name's Adam Hand, and the session title today is Speed of Construction. We've got 3 great presentations coming up. And the whole idea with those presentations is to set up the importance of the speed of construction so that we can have some breakout groups. And I'll talk through that in a minute. So, again, welcome to Florida, and thank you for being here this afternoon. This is the outline for the workshop. And the idea, as I said, is to have 3 presentations. John Epps is going to talk about the speed of construction and why it's important to our industry. Jeff Lamantia is going to talk about road user impacts and how important it is to the users that we use asphalt to build pavements. And then Brandon Millar is going to talk about some examples of successfully completed projects under the sort of rapid construction model. And then we'll talk about the workshop itself, which will have a breakout sessions and talk about, our goal as AAPT is to lead the advancement of asphalt pavement technology. So talk about how we prepare for this change that's coming relative to speed of construction. And then we'll have a report out from those breakout sessions. And we're fortunate today to have a group of new members that are going to help us with the breakout sessions. Could all the new members please stand up? They're going to help us with the workout sessions today, or breakout sessions. Yeah, so there are 8 new members that are going to help. We're going to have 7 sessions, or 7 groups, and we'll talk about how that's organized when we get to that point. And thank you all. And then we'll, as I said, we'll wrap it up with a Q&A. One thing that I think it's really important to sort of getting started here is that what we want to do is have the speakers make their presentations, and if there's a need for clarification, we could take a few minutes for clarification, but to really stay away from Q&A, because that's really what the breakout sessions are about, is to have the conversation, and then we'll come back and have a Q&A with all the presenters up here in a panel forum, okay? So if you do have questions, there will be mics set up, but the idea is not, it's just really just to ask questions for clarification. With that, those are the 7 topics that we'll be talking about in the breakout sessions. And the idea there is to really to think about what we have to do to prepare from looking at speed of construction from these 7 different perspectives. And when we get to I'll stop here and introduce John. And when we get to the group breakout sessions, we'll have about 30 minutes or so. And we'll be looking for sort of top 5 ideas. And the new members will be passing out numbers for groups, if they haven't done so already. And with that, I will, again, thank you all for being here. Apologize for being late getting started. And I'll also share with you, that we're doing something that's never been done at AAPT before, and that is we're streaming this session. The symposium session is going to be streamed on Tuesday. And so we're streaming this session as a sort of a practice run. So I don't want to welcome anybody that's online also. And go ahead and introduce John. I know many of you know John. John is an honorary member here at AAPT. John went to school at UC Berkeley, and I know Carl's here, and I'm sure proud to see John up here today. And I was fortunate to have John for a mentor, and he's been a mentor all my life, and he was my advisor when I was in school, so I have a tremendous amount of appreciation for John and what he brings to our industry. John's got this vision. You know, I've always told John he's 10 or 20 years ahead of us. And this is one of the topics that John has been talking about for 20 years. So at any rate, I'm glad to have the opportunity to have John share his vision on the speed of construction and try to help us all understand how important it is moving forward. Please welcome John.
Well, I'm at the podium to make sure that the average age goes up a little bit, and I think I'll be successful in doing that. We have some great speakers today that are much younger than I am, and I'm very proud of that. Good to see all the young people here. Thank you all for coming and participating, and I think you'll find it very, very rewarding. If I press this, something happens, I think. Is that right, Adam? No, you have to cue something up. Leave the technology to the young people.
Sorry, John. Yep, we need presentation 2. We're having some technical difficulty in the podium, and so we're being run from back there, and we don't have control up here today, so there we go.
And remember, we'll have driverless vehicles one day that'll have the same technology that we're experiencing today. I think we did have driverless trucks at West Track, didn't we? That was 1993, something like that, Adam. So we're going to take a little bit of look at speed of construction today, and it's something that's not new like most things that we deal with, but we're trying to make some nice changes in that and get it launched a little bit better across the country, and just talk to you about a few things that have gone on in that area. We've started an effort again in Texas, and you'll hear a few things about that during the slide presentation, but it's something again that has been around for a while. It's actually, there's several projects that have been placed around the country that have been very successful. Some of the other speakers will talk about some specifics on those, and I'll just mention 1 or 2 to do that. So we've used accelerated construction as sort of our name in some of the areas as well. So you'll see me refer to it as accelerated construction. ABC is accelerated bridge construction, and that used to be a really very active program. I think there was a difficulty in South Florida here a few days ago that was associated with accelerated bridge construction. So there'll be a lot of things being investigated and looked at that. I don't think we're going to make the same mistake in pavements. It's hard for a pavement to fall down too far at least. So why? And I think it's pretty evident when you think why we want to have rapid construction or accelerated construction. And if you look at these numbers over a 10, 20-year period, it's very evident, and it continues on and on and on. The number of vehicles on our roadways, including trucks, it continues to increase. It's forecast to continue to increase. That's going to go up a tremendous amount during that. The vehicle miles traveled has increased substantially, and the number of roads that we're building is very, very small in comparison, lane miles, however you want to look at it. Probably a more telling map is this one right here. This is a forecast of the national highway system from the two periods you see here from 2011 to 2040, and you can see the red on there, which indicates severe congestion, and it's forecasted to be much more congested in our urban areas and non-urban areas for that matter. And remember, we're going to have to rehabilitate, maintain, and reconstruct our pavements in those environments. So we're going to have to do it quicker. There's just no question about it. Probably the more compelling thing to me, because these are our taxpayers, if you just stop and think about it for a minute, what the public sees in highways and what they notice is when we're constructing or maintaining our roadways. They really don't get too involved in the planning and design, specification development. What they see is somebody trying to work out there or working out there, or a bunch of cones up with nobody working. And that has led to a lot of ill feelings. But it's the taxpayers that we want to make sure that they get a good, safe work zone that's people get in there and get their work done and get out of it in a very short period of time. So we're very visible to the public during the construction operations. And then you see the safety and economics part of it is extremely important too. When all else fails, if you want to justify something, go to safety and economics. It's a way to justify things. It's a good reason to justify them, no question about it. And we want to keep our traffic out of the work zone just as much as we possibly can. And the cost associated with these are both direct and indirect costs, as you see more details up here on the slide, and I'm not going to go into those. And the direct costs are the driving public and the truck freight hauling operations that occur in our highways. The indirect costs are associated with adjacent businesses and vehicle damage and things like that are not considered very often. But in the end, we pay for all that. Society pays for those costs. So they're real, but they're not in the DOT budget or the city budget or the county budget, but they are real costs that are coming out of our pockets. Just some examples of some money. These were just have to be 3 projects I went in and got some data out of. And these were projects only user costs now, not non-user, but just user cost. And some of these projects that we're looking at here, nearly $500,000 a month just because it didn't get built sooner than what it was. Some of these projects were delayed 36 months or more by a variety of things in the planning and execution stage and not necessarily in construction. There's a caution here though, and that is that not all projects are suitable for rapid construction. We can't go into this thing and say we got to speed up everything. It's not going to work that way. We need to pick a few key projects and do a very good job on those to get this thing initiated. And then I think it'll be the norm, at least to speed projects up a certain amount, maybe not as complete as we would do others. So that's the reasons to accelerate or speed up construction. So what is it? Well, we can define things the way we want to. Certainly in greenfield construction, there's some greenfield construction, new construction going on. And when those kind of projects occur, we are able to do a number of things associated with that. And there's some projects around the country that have been accelerated quite a little bit when there's traffic not involved in those. We will not talk about those today. But I'm using construction term here to not only mean the greenfield construction, but capacity improvement kinds of projects. Reconstruction are certainly something we think of very often and try to speed it up, and rehabilitation as well. But we also need to throw in major and minor maintenance operations in those things too, because they interfere with the driving public and they occupy lanes, traffic, et cetera, et cetera. So it's really this whole thing ultimately. But the focus so far has mainly been on reconstruction and rehabilitation programs that states have concentrated on. This whole thing starts back in the planning and programming stage, goes through preliminary design, goes through the various kinds of environmental efforts that are necessary to get a project launched, Right away in utilities, if you talk to contractors, and I'll emphasize this a little bit later, those are the main things that contractors worry about. Give me a so-called clean project, free of all of that sort of thing that they would have to deal with during the project, because that forces a great deal of detail. And then we get to the plans, specifications, and engineering, and finally to the construction phase of this thing, which we're trying to reduce. But if you don't start at the front end of this thing, you're probably not going to have a very successful program. Now, the goals that we have talked about in a lot of these accelerated or rapid kinds of construction operations is not to reduce them by 20%, but to reduce them by 20 to 50%. So we're talking about a substantial reduction in time that we're going to be out there in these projects. And there are projects that are on the books today that have got 75 and 80% reduction in time associated with them. They normally involve shutting down freeways for periods of time or rerouting traffic around the other ways. Accelerated construction or rapid construction is a balance between what industry can deliver and what the DOT, in this case it was Texas, wants. Those sometimes are two different things. Industry can deliver things that increase cost. In some cases, we've seen accelerated construction or rapid construction projects be lower in cost than what they originally were. So you don't always pay a premium for it, but industry can only do so much so fast. An incentive to industry, of course, will speed this up. And then there's a number of things that we're going to be talking about during the rest of the day today that really contribute to this whole thing. And this is the traffic management part of it. The work zone safety are extremely critical parts of this. Public information is not up there, but it's one of the more important things that you have to go through to have a successful project. And then there's the user, non-user costs that we'll talk about a little bit later. Materials aspect of it, which hits us right between the eyes. I hope we will talk about that a lot today. There's some things we can do there. And then there's an equipment action of this. We don't have the necessary equipment today in our fleet of construction equipment necessary to speed our projects up as much as we possibly can. So I see the equipment manufacturers playing a key role with us as we move towards really developing this kind of a thing. There's some information out there. We recently had 7 workshops around Texas, for example, where we introduced accelerated construction, left them with guidelines and various kinds of reports so that we had 700 engineers in one state attend workshops in an attempt to launch this kind of a program. It won't be launched overnight. It's going to take a tremendous amount of effort to follow through on this and make sure that all 25 districts actually do look for projects. They're not just projects for urban high traffic areas. They're projects that you can deliver in rural areas very quickly that really make sense in some cases. Maybe the economics are not driven at such a high level, but they're very important to do that with. Let's take a look at some of the history here just very quickly. Like I said, most things these days are not new. They're just better technology associated with them, brighter people working on them, and we're making more progress. So in 1988, I can recall a meeting out in our new building at that time at the University of Nevada, Reno, and the Federal Highway Administration there was several states. I don't know if, Adam, you can remember this or not, but I don't even know what we were talking about. We had a session where we just brainstormed things. Becky, were you there? We started saying, well, what do we need to do? We really need to get our projects done quicker, get out of the public's way, blah, blah, blah. So we want to get in there, we want to stay in there, get the work done, and we want to get out, but more importantly, we want to stay out. We want to do it with quality and get out of there and stay out of the public's way for a period of time. So that was sort of a launch of a statement like this. California picked it up and changed it a little bit. TRB task force were formed. State of the practice sessions were held. The technology transfer sessions were held. And then it led to a Project Pegasus in 2003 where some projects were launched around the country with these concepts. One of the projects that was launched about this time was the reconstruction of what is called the Katy Freeway. It's west of downtown Houston. It's a heavily traveled corridor there. It was a $2.6 billion project over a planned 12 years, and it was reduced to 6 years. And the benefit cost ratio of this was of the order of 9-to-1. And this included user and non-user costs. Now, these are pretty good economics to me because, again, society pays for this one way or the other. So if you can get $9 for every dollar you spend on this, it makes pretty good sense. So what are the opportunities? This is what you folks are going to be talking about a little bit later today. Materials, time, temperature, strength gain. This is all very, very important to the materials that we deal with. And you think of hot mix asphalt, well, the construction time, we can do something with that, I know. As soon as we cool it down, we have pretty good strength. We can get traffic back on it pretty soon. That's a big advantage. What if we use emulsion systems or other kinds of systems with asphalt binders? What if we use hydraulic cements and those types of things? So those are important. Removal and replacement. We spend a lot of time, effort, energy on removing pavement materials and replacing them. And if we can somehow go around that and reduce that time, which we can with various techniques. Production rates are important. Transportation to and from the work site really is a major problem that we have to encounter and solve somehow, and then the placement operations. Want to, again, emphasize equipment a little bit. I don't think, again, we have the equipment necessary to really speed up construction as much as we want to. I think there's plenty of opportunity here for the equipment manufacturers to work with us to get the equipment necessary to do this. There's been a few items certainly that have been developed over the years that speed up construction because that's more economical, and the contractors want to have more economical operations, no question about that. A big area, process control, quality assurance. I think this is a huge area. I know we've had at least 2 national initiatives that I'm familiar with trying to develop more rapid tests for quality control, process control, or quality assurance for that matter. And we haven't done a good job at it. I don't think we've seen any major breakthroughs. We've got a little bit quicker, cleaner way of determining asphalt binder content as an example of a successful project, but we still do a lot of sieve analysis the old-fashioned way, and we do a lot of other things the old-fashioned way. We need some major breakthroughs here. If we're in a high production and placement environment and we get our tests back after we placed about 20,000 tons, it's not going to help us too much. So we've got to have some better tools to do this with. We need more rapid tests. We need quick feedback to the producers. We often do tests, but we don't report them back. We don't get them back in a timely manner to make plant adjustments. And this is a problem. So we have to manage our data and ensure our quality as we go through this. Traffic control is another major area that we have to deal with. I'm not going to go over all the words that are on here, but I think you get the point that if we can't control traffic efficiently and effectively, then we're not going to have a good work zone in which we can speed our operations up. And I don't want to forget workforce, and I think some people overlook this. Somebody has to go out and build it. And the people that go out and build this are going to have new skill sets. If you look at quality control, quality assurance tests, we're probably going to be dealing with new types of materials and new equipment. We have to learn how to work in a congested work zone a little bit better. The shift lengths, they can't be 20 hours a day for somebody. It's not going to work for very long. If you have a hard time getting personnel to and from the job site, you may have to have some kind of a facilities at that job site for these people to rest and to sleep. So these are key things that have to be addressed here. And then the economic incentives, talking to the contractors and talking to other folks around the country. It can't just be one accelerated construction job in the state of Louisiana and not followed by another one for 20 years. That's not going to work. It's going to have to be a series of projects that the state's going to put out. The contractors know these are going to come along so they can invest in the people and the equipment and the technology necessary to put these things in place in a hurry, get their return on their investment. Bonding capacity is of concern to some contractors because you could have a lot of projects of short duration going on and you have to have a large bonding capacity. Probably be a lot of consortium of companies that will be formed, partnerships that will be formed much like you see in design, build, and public-private partnerships that we've experienced today. And the backlog of work, which we always as contractors like to have a big backlog of work, well, that's going to get a little scary because they're going to be short duration projects, and that's going to be a concern. And the risk is going to go up. Why? Because it's different than what we do today, and that's going to cost us money for a while. Adam asked me to talk a little bit about the contractor's view. I did work for a contractor for a while, and Adam did too, and a lot of other people in this room. And I listened to the people at the workshops that we had in Texas. We probably had a total of about 140 or 50 different contractor representatives, and I tried to listen very carefully to them. They need to understand their risk because if they don't, they're going to bid their risk in one way or the other. So risk have to be identified and taken care of as best we can. Design considerations, they mentioned a lot of design elements that people put into specifications, either consultants that are doing the work or the state DOTs, that just really don't lend themselves to repetition of work. And repetition of work is important for them. Contracting methods, some are better than others for this rapid construction. And then there's also contractor involvement. I want to mention that they need to be involved in the planning and the design stages of projects. And you can do that not showing favoritism by involving the Associated General Contractors or some association such as that to invite all people to come in and to comment and help you through this. Major risk. And risk, again, are very important. Again, contractors want clean jobs. Right-of-way acquisition is complete, utility relocation is complete, environmental requirements have all been taken care of, historic preservation issues have been resolved, archaeological sites are sometimes surprises, as we all know, you're trying to avoid those. Railroads came up in every meeting we had. Evidently there's something about railroads that just don't cooperate very well with us building highways, and that is true all over the country. They also want to have somebody at the job site that can make a decision quickly. If you have an issue that arises, resolve it. Get it taken care of or move it up the ladder in a very quick fashion. And some of them are using risk registers or risk matrices to anticipate what's going to happen and have a resolution in mind before it even happens in some cases. Design considerations, just a few of them that you see up here. Minimizing profile changes was a major one that they identified. Minimizing mobilization and demobilization. Don't have them mobilized 3 or 4 times to do some work on a project. Try to do it one time if you possibly can. Create workspace. Very, very important to have workspace to put material and equipment, et cetera, at all times. Get in and get out of there. And then the design of repeatable features was another major element that they mentioned. Contracting methods. You can see those on this slide here. Lane rental was certainly one of them. A+B contracting was another. Construction manager at risk was another item that was put out there. And the use of incentives and disincentive was mentioned by every contractor as being a very, very important thing to go through here. So contractor involvement, again, is important in the planning and design review, the partnering and the workforce availability, because there's issues with that in certain states, certainly, that we have to overcome. Construction considerations are pretty much the same as we always have, except that things are now in a big hurry out there. And again, equipment and closures, things of that nature have to go forward on that. Moving forward, there's a few slides, Adam, but to try to keep us on time, I'm not going to show those. We'll leave that up to the discovery of the people in the audience. And it's time to get off of the stage up here. Any questions or clarifications that you would like to have? Not questions about the presentations unless it's not clear. I think that's what Adam said. So we're going to be rapid, we're going to accelerate, we're going to be quick, and we're going to do it. We're going to get in there and stay in there and get out and stay out. And that's going to be extremely important. If we do a really good job of this, the taxpayers' money, I think, will follow, or it will lead that a little bit and then follow it. If we can convince the driving public that we're providing something to them and staying out of their way, it's going to be a major, major thing. Thanks, Adam.
Thank you, John. Let's give John a round of applause. Yes, just as anticipated, John did a great job of setting that up for us. And he's walking by Jeff Lamantia right now, and they're sitting away from each other because John's an Aggie and Jeff's a Longhorn. So this is the first time at AAPT for Jeff because he's not a materials guy like the rest of us. He's a transportation person, but a unique person that works in the transportation field. And he's an associate professor at Auburn University, and as I said, he did his graduate work at UT Austin. But he's been doing some work for Napa recently that's really, really compelling. And he's going to share that with us today. And it's all about, really, from my takeaway from looking at it is that, we have the opportunity to really accomplish some of the things that John was talking about because the users really do care. And he's going to share that story with us. So please welcome Jeff.
Got it. Okay. So great, okay. Getting all the technology down before I start going and get too many things going at once. So thank you so much for inviting me to come talk. Yeah, as you said, I do a lot of transportation things, and so I'm meshing in the transportation behavior and cost and economics into work zones. So you set this up perfectly, John. Thank you very much. And so I'll be talking about a project that we did. Great. For Napa, looking at road user costs and local business impact costs for work zone projects. And there were a number of people that worked on this. This is the list to thank, including folks at Auburn and the folks at Napa who were so supportive and allowed us to do some really innovative things with this. So John already gave a nice summary of why work zones are really important, but I had some cool statistics that came out from Federal Highway here to give us a sense of why we care so much about road users, and I highlighted the bottom two ones on this list. The first is that motorists encounter an active work zone 1 out of every 100 miles driven, and that incorporates both local and long-distance trips. That is a lot of interaction that we have to worry about. The second thing is that work zones on freeways account for nearly 24% of non-recurring delay and 10% of overall delay on our interstate system. That is absolutely incredible, the impact that we're having on motorists around the country. And so what impacts do we have? Well, they fall into a number of different categories. I know we all have experienced them driving through here. When I drove from Auburn over here, I hit a number of work zones to get through here, which slowed me down a bit. And the idea for this project was, how do we quantify these impacts? There's a lot of discussion about how much of a pain it is to sit through them, but you can see they can cause crashes beyond just wasting time. And then this woman, I hate to throw her under the bus, but she's on her phone. The idea here was that she was trying to get business done, and this definitely has indirect impacts on getting work done and access to jobs and things like that. So we broke it up into 3 major categories. We've got road user costs, crash mitigation costs, and local business impact costs. You can see our definitions over here. But the idea is that it's broken up both directly and indirectly for people in their cars and the freight that's moving through local areas. The crashes that have the potential of occurring within work zones and what we can do to minimize those. And then lastly, the local business impact cost, which is not something that anyone has studied previously. So we went through each of these. And again, kind of to prompt some of this discussion of why we think this is important, the ways that we can use this quantification of impacts is to change start times, change the work durations, come up with some innovative scheduling. And our goal for this project was to be able to say, for every hour that we spend in the roadway environment, what are we incurring for costs in these 3 different categories? And so you can see, if you don't even do our big analysis that we did, just think basic. This comes from the California Department of Transportation. These are the percentages of the ADT that's going through a work zone based on the times. They did a huge statewide survey, and you can just see, if you pick a certain start time, the impact that you'll have on the traffic that goes through there. So even at a basic level, we get a sense that how we schedule these things is quite important. So our data collection for this was broken up into 3 categories. The first was our road user costs. This one, we found that there's a lot of information out there in the U.S. From Federal Highway, from the DOT, from state DOTs, trying to quantify these different impacts. We've got lost time costs, vehicle operating costs, and vehicle emissions costs. And there are lots of reports that show this, but nobody put them together in the way that we did with this. So we collected information to quantify what these are. And to give you a sense of scale, so the idea here is the sources for them come from the main ones that we worked off. We're trying to make it representative across the country. So we found information that was incorporate different regions, different states, so you can pick numbers that are appropriate for where you are. And of course, those sources came from Federal Highway and AASHTO, but we backed things up with the U.S. Census, the U.S. Economic Survey, and NEPA for emissions information. Lots of sources came together to build these tables of all these impacts. So to give you a sense of what some of them are, there isn't time to go through the 20 some odd different costs that we incurred for just individuals and freight vehicles moving through the work zone. But the first one that I thought was really interesting was the value of time. Now, we associate a value to every minute that we spend in our car, and when you are driving through a work zone and you get delayed, that is a both direct and indirect impact that we have. More direct if we're talking about freight that's trying to move through an area and we're delaying their processing. But I think it's really interesting what we see in the trends here for the value of time. This is the dollars per hour that your time is worth. And for the different travel purposes, you can see work and business. If you get delayed in there, in a work zone trying to get to your office, it's lost work time, and so we quantify it as a much higher value. You can also see that 12 and 18, when we talk about the economics, the impact that you feel if you were going to do something fun or going on vacation, which would be the inner city one, most likely, rather than the local one, is going to be much higher. That you don't mind sitting in there if you were going to work or going to go to the doctor's office or something, but you are really upset if you were late to go to a vacation. The second category was fuel consumption, and this was another thing, again, for personal vehicles and freight vehicles, very different emissions and fuel consumption for them. So based off a speed of your roadway, you can see the amount of fuel that's being lost by just sitting in traffic for every hour that they sit in traffic there. And of course, this is per vehicle, that the more vehicles you have sitting in traffic, this gets increasingly bigger. And then the emission rates with this as well. This came from the EPA, again, based off traffic speeds, that the stop and go aspect of a work zone actually makes it worse, that every time that we hit the brake, we're releasing more emissions into the area. So there's an additional level to this of the amount of congestion that you have sitting in a work zone can increase these levels. But this is kind of a baseline to give you a sense of all the things that come out of our tailpipes that we can quantify as a cost to both people and the environment. Now, the second piece of this is our crash mitigation costs. And to figure out the likelihood of crashes, we dug into crash records, again, representative across the country. So we collected information from the Highway Safety Information System, and because I was from Alabama, we work very closely with the Alabama Crash Database, the CARE database. So we had 8 representative states. 89,000 different crashes were involved in our analysis. So we had lots of information about the factors affecting crashes. And the information comes from 2008 to 2015. We deleted the really old stuff. So we tried to make it as modern as possible. And the key way that we organize crashes, if you're unfamiliar with this, is based off a Cabco scale. Every crash gets assigned a score, K being a fatal crash, O just being possible or property damage only. And then it kind of scales up from there. That's possible injury, evident injury, incapacitating injury, and then fatal injury. And you can see this comes from Federal Highway and an analysis with the U.S. Economic Census at the cost per injury of every time that you experience one of these crashes. There is a both direct and indirect cost of all the things that accumulate based off that type of crash. So these can be pretty significant in the amount of impacts that they have. This includes both things to the people that are involved in the crash, but also the impact to the delay on that roadway, again, of all the cars that sit in that traffic. Now, this is also an interesting statistic that comes from Federal Highway, that a work zone crash occurs every 5.4 minutes. That is an incredible statistic that shows us that this is not a category that we can kind of just ignore. Across the years, interstate crashes have changed considerably, but work zone crashes have not. They've maintained about the same rate since 2005 is when we went back to that. So to give you a sense of the crashes that we had in our database, we had representation across the entire country. Now I want to be clear here that by the regions that I'm showing, does not mean that certain areas are more safe or less safe. It just means that they were more represented crashes within the database that we had. Perhaps the exposure was just considerably different between the different regions. So that's an important thing to keep in mind. I'm not throwing any regions under the bus here. And then in terms of the types of crashes, though, you can see there are a lot in that no injury or property damage only category, 55%. And that's pretty consistent, actually, across all the states that we looked at. No matter the number of crashes, those proportions are about the same. So it's kind of nice that the fatal crashes were not the biggest one, but you can actually see that's a pretty, 16%, it's a pretty large proportion. And then the third category of data collection was our local business impact costs. In this case, we had nothing to work off of. There was no existing databases for us to go to, so we had to generate our own information. And I thought this was actually the most fun piece of the project. So we developed a stated preference representative sample survey, and that's geek speak for saying that we asked people about trips that they had made and then gave them hypothetical scenarios to say, well, what if we threw a work zone at you that affected your travel and how would impact your trip? So we worked really hard and had great support from NAPA to make this a representative survey that we had a paid sample from across the entire United States. So regions, age groups, incomes, and genders were all matched to the US Census. We had information collected about demographics, current behaviors, different scenarios, and I'll give you an idea of what those are in just one second. But at the be-all, end-all, we had 770 responses, a full, complete setup from all these different scenarios. And we put these people taking the survey through the ringer. We asked them lots of different things and got great results from it. So here you can see the representativeness, both within the regions and the ages. Very representative of the US Census across the country as where we are right now. Now, the idea of the example questions here is we started by asking, well, demographic information to make sure we were representative, but then when it came to types of travel, we asked, for example, about grocery shopping. Think about the last time that you traveled for grocery shopping, and then we asked how much you spent at that store, and there were a number of categories that you chose from, and then how long it took you to get there. And we kept these, oh, you can't see this, I'm sorry. There we go. How much you spent, and then how long it took you to get to that destination. And there are all these different choices for what you could do. And then we threw the wrench at them and said, okay, consider that the trip includes now a work zone that adds 20 minutes to your travel time. And this is just one example. We actually played around statistically representative groupings. So we did short, medium, and long durations and delays attached to it. So in this example, we have a 20-minute delay and a duration that's going to last a week. And so we did this with short, just an additional 5 minutes, but then also much bigger as 45 minutes. And then the duration could last a day, a week, or a month. And so then, based off all of these different options at you, and they were randomly generated for each person, we asked these options. Would you still take the trip? Would you reschedule the trip for another day while construction is still happening? Would you reschedule while construction is still happening and there's no longer a delay? Would you go somewhere else, or would you cancel the trip entirely, including doing online shopping, such as Amazon or something like that instead? Well, to give you a sense for this, here are different categories of the responses. This is the grocery shopping one. And you can see here, I've broken it up by the delays and the durations and the percentage of how people responded. So again, it was equal proportions of the entire sample fell within each of the different groups. And you can see a dramatic difference here. We were really surprised with how significant people responded. So the darker the color means the more likely you are to continue doing what you would normally do. And then the lighter the color means the less likely you are to do what you were going to do. So within a 5-minute delay, pretty much everybody across the board jumped in and said, yep, we'll just do what we used to do and we'll suck it up and go with it. But as soon as you jump into that 20-minute delay, it gets into those avoidance choices where you're going to either go somewhere else or cancel the trip entirely. A dramatic jump up there. And same thing for the 40-minute delay. Interesting, the day, the week, and the month did not have as much of a impact on these choices. Now, this is an overall representation, not broken up by demographics, and you'll see that that actually is quite interesting as well. We had personal business in here too, but to save on time, I'm just focusing on two. So there was grocery and then leisure, which was kind of fun things, going out to eat, going to the movies. We had a list of leisure activities you could think about. But the trends were also very similar. But the going somewhere else and the cancel the trip entirely were much bigger for those 20-minute delays and 40-minute delays for these types of trips. We saw that the grocery shopping was kind of non-negotiable. We have to go grocery shopping, so you're much less likely to cancel it entirely. But when it came down to personal business or this leisure trips, people were more likely just to cancel it outright, which was surprising to us. We weren't expecting those dramatic hits. Oh, sorry, I keep not hitting the same button. There we go. And then for model development, that's the last piece of this, is putting it all together, of trying to understand what are the important factors here. So we broke it up into 3 different models. The road user cost model is really just a sum up of the 3 major components, our lost time, our operating costs, and our emission costs. And it's just the combination of each of these different things in here. You can see I'll call it a couple of different things, the values of time versus your occupancy for the lost time, for example, and then for the emissions costs, the emission rates, and then the type of vehicles that you have going in there, just summed up for all of them. For the crash mitigation costs, we estimated a model for this one. Actually, it wasn't just a summation of rates. This was actually what we refer to as an ordered probit regression model based on crash intensity. And if you remember back to your stat days, this is just a regression that adds up into a categorization. So you can think of it as a scale that as you add in different characteristics, you go from the low end of your scale, higher on your scale, and the scale is crash severity. So low end, of course, is your property damage only, all the way up to your fatal injuries. And you can see the equation here is just a basic regression equation, but there's that added layer that as you start moving up the scale, there's breakpoints that throw you into those different categories that we have here, those 5 different categories. And to give you a sense of what some of the most important pieces were, the list that we have here were things that led to more severe crashes. Weekends were more severe. Rural areas had more severe crashes. The higher your speed, the higher the severity. The location of different roadway types, divided highways actually were the least safe type of facility, led to more severe crashes. And then the volumes of vehicles on your roadway, especially as you started getting into those stop and go congested areas, led to more crashes as well. We also use the same model structure to look at our local business impact costs. And for each individual, you can predict how they're going to respond based off of delay and duration and their demographics. And actually, there was a lot of variation that happened within those demographics, that not everybody fell into the same groupings. So again, think of it as this increasing scale, and we estimate those breakpoints between each of these different categories to tell whether you're just going to stick with the trip or you're going to cancel completely, because it's kind of an increasing scale of avoidance, of inconvenience and avoidance. So the interesting trends here were that in urban and suburban areas, people were much more likely to just flat out say, nope, I'm going elsewhere, or I'm going to cancel it entirely, versus the rural areas. And that mainly had to do with opportunities. People in rural areas don't have the choice to go somewhere else. When we looked at regions, the only region that had a significant impact was the West Coast. And the West U.S. Census region very significantly jumped into the just go elsewhere or cancel the trip entirely. Their patience was not as high as the rest of the country, I guess. And again, delay and duration. The higher we got for delay and the higher we got for duration, again, not surprisingly, more likely to go elsewhere. or higher on this scale for avoidance. Also, the less you spent at your destination, the more likely you were to go elsewhere or do something different. And the shorter time that you were going to that destination, you were more likely to just skip what was happening. Kind of goes to show that the less you're spending and the less that you're traveling there, a 20-minute delay is going to have a huge proportional impact on that trip. And if you're not spending much money there, well, then you probably weren't that invested in going to that location in the first place. If it's a grocery trip where it's you're spending hundreds of dollars, it's your weekly, monthly grocery trip, you kind of have to stick with it. Okay, so what we did was we took these things, which we thought were interesting from a behavioral standpoint, but not so useful for users, and built a tool out of it. So you don't actually have to worry about the nitty-gritty values to plug in here. We developed this tool that's based in Excel, so everyone has access to it. And you can see the breakdown here. There's the 3 different blue groupings, which are inputs based off your roadway characteristics, your surrounding area characteristics, and work zone characteristics. And then it actually runs a simulation in the background to figure out all the different people that are going to be moving through a work zone based off the given durations that you have, and it figures out what each of those people are going to do, especially when it comes to those local business impact costs of are they going to continue that trip or just cancel it entirely, and the costs associated with it as well. So the green part of this highlights those pieces. So here's my overview of how it works. We've got those 3 different components of roadway characteristics, surrounding area characteristics, and your work zone characteristics. And talking about time and scheduling and why all of this is important, that's where you can do kind of a play around of if I reduce the amount of time that we spend shutting down the roadway for this work zone, what are the costs? And then if I can reduce that by 50%, how much for that benefit cost ratio am I going to be saving from our road user, our crash, and our local business costs? We pull in information at the census region demographics for that simulation that runs in the background. If you have updated information for your local area, you're welcome to plug it in. There's a way to do that. But if you don't, we already downloaded everything for all the regions within the country. So you can use the basic information that's there, and it runs through and predicts all the different type of people that would likely go through your area based off of ages, incomes, population, or household characteristics, things like that. And then once they all go through there, it calculates those road user costs for every vehicle, the crash mitigation costs, and lastly, those local impact to your businesses. And we tried to make the tool as easy to use as possible. So it's a 3-step process. You identify the characteristics of your work zone location. Again, this works really well for the what-if scenarios. If you can save time, you can quantify how much that time savings will be. Then you enter that information into the tool, and then there's just a button that hits calculate. Depending on how many vehicles you expect to go through there, because it's running a simulation on every single vehicle, it may take a few minutes, but it will pop out with your final answers. And to give you a sense of what those inputs might be, here's our list of the roadway, surrounding area, and work zone characteristics. You can see everything from the AADTs to whether you're in urban, rural area, the amount of freight that you have, the type of development in terms of shopping, residential, things like that, and then your work zone characteristics. These are things that we would have more control over in our project scheduling. And then, of course, we have our outputs. This was really important to us to put it in a means that were easy to communicate with decision makers. So it breaks it up by road user costs, crash mitigation costs, and local business impact costs. And you can see that there's a cost for different types of vehicles. And then we broke it up by hour, per workday, and by project duration. So you can, again, play around with those values to get a sense of exactly what those costs are by type. And then it sums them up for a total impact cost. Now, I want to highlight the numbers that you see here. This is a representative example that we did of a project that was happening in downtown Auburn, but we played around with the numbers in general, and you can see the scale of the impacts is quite dramatic, especially those local business impact costs. It falls in the $2 million project duration range compared to the road user costs, that's $1 million, and then the crash mitigation costs, which are significant, but that's only about $7,000 comparatively. So again, all three of these are really important for comparison. Okay, and then to wrap it up, this idea of things to think about for our breakout groups, this idea of user and business costs have many different components that we brought together in a new way. Our road user costs, our crash mitigation, and local business impacts. We really do need to understand traffic composition to fully calculate these costs. That's a really important thing in that simulation piece, that if you don't know who these people are, the amount of freight that you have in there, that could be a problem. Because those freight and vehicle costs experience very different impacts in our calculations. And then lastly, just a small increase in travel delay can really do have a significant impact on businesses that has not been quantified up until this point. And it's really interesting to be able to quantify and show that off. So there we go. Thank you so much.
Thank you, Jeff. That was a great job, and the business impacts are truly incredible, and it's something that hadn't been quantified, and again is really valuable for us to be able to communicate how the material that we all love so much can help businesses save some money. With that, we'll go ahead and Brandon Millar is with the California Asphalt Pavement Association, and Brandon, he spent about 20 years in industry working. He worked for contractors, he worked for public agencies, he worked for material producers, and Brandon is in the state of California, which Jeff referenced many times along the way there. And California has experimented with speed of construction, and Brandon's going to highlight some examples in California. And with that, I'd like to welcome Brandon.
Thanks, Adam. Exciting. Technology is great. Sometimes it takes us a little bit longer to get started, but once we get going, it's a really cool thing. Love the streaming. Hi, Mom. I think you got the link. And so let's get going with speed of construction and Caltrans. First off, I want to recognize really the folks that put this, the information that we have in this presentation, UCPRC, primarily John Harvey, and also Caltrans. All of this information has been shared in one way or another before, and in doing this, wanted to consolidate it into one place so that all of you can get a feel for how Caltrans has dealt with and utilized speed of construction concepts. So what we'll basically go over is how they first really got to understand it, some of their experiences. I'll focus primarily on their I-710 project. I know that there's a couple folks in the room who were hands-on in that project. We also talk about technology. You know, how do we utilize some of the new technologies, primarily on the software side, to improve speed of construction? And then we'll talk about the one big thing that is important in everything that we do in life. It's communication. I'm sure if all of you look at either a successful project that you were involved in or an unsuccessful project, a project with a lot of challenges, I'm sure you're going to be able to find out that communication had something to do with that success. Speed of construction, some of the strategies that are used, they look at different types of pavement structural designs, utilizing different technologies that a lot of you are involved with the asphalt pavements. How can we take our current structural sections, make them thinner, and still have high-performing pavements? Also looking at different types of closures, whether it's continuous, full interstate highway closure, or if we're just looking at directional closures, looking at those. Also, traffic management planning. How do we address for all of the traffic that typically goes through that corridor? Where's it going to go? How are we going to plan for that? Also, continuous monitoring, as was mentioned before. It's making sure that we have folks there that are constantly keeping an eye on what's going on and can react as conditions change. Public outreach, communication, not just with the folks who are responsible for the project, but the areas around them, the people around them, the region. And then with that comes what's our alternatives to what we're going to be taking out of use in the system. Well, how else are you going to learn from anything than by having a pilot project? And what better way to have a pilot project than to have an earthquake? And so when we look at in 1994, big Northridge earthquake happened, 6.7 magnitude, big shaker. If we were back in California, we probably could have arranged what that feels like, but out here in Florida, not so much. Lot of damage. And one of the biggest places where we had the damage was on the I-10. Major interstate that runs right through the heart of Los Angeles. Bridges, 4 of the major bridges were completely destroyed during the earthquake, and they had to figure out how are we going to get that up and running and back going. We anticipated that the cost per day for regional, for the economy, was about $1 million a day of lost revenue, lost transactions. So we needed to get that road up and going as fast as we can. It's how goods and services move throughout the valley. It's also how people get to work, get to their shopping, whatever they need to do. Contractor was C.C. Myers on the project, awarded the contract. It was a $15 million project. The design, which was done very quickly, was for 140 working days. They were offered incentives to shorten that up as best they can. And when all was said and done, the contractor was able to complete that work in 66 days. Yep. That was the headlines for the LA Times. The incentive on that project was almost $15 million for finishing it early. Now think about that, $15 million, that's a lot of money, and from a lot of agencies, they look at it and say, oh my gosh, I just increased my budget $15 million. What am I gonna do, from 140 to 10%? But when you compared it to the cost in the economy of lost transactions, you're probably looking at a savings of about, by finishing it early, $59 million. So you take $15 million so you can save the economy and the region, $59 million, that's not a bad thing to be. But from, just like all good pilot projects, what did you learn? What did we learn from it? And so these are some of the key concepts that, and we've seen this thread through all of our, through the previous presentations. You looked at what made it quicker, why were they able to complete the project ahead of time? Use of innovative materials. In this case, they were using fast-setting concrete on ramps, different types of high-performing materials that they can have that can set quicker, get the strength that they need so they can open it up to traffic. Also, not necessarily by design, but because of the situation they were in, complete closure of the interstate. Here's one where the road was completely closed, no traffic on it, so the contractor now had all the flexibility in the world in regards to how are they going to build this. You don't have to worry about managing traffic. You have full access to the project for coordinating multiple different operations going on at the same time. And then, of course, the incentive side of it. Because what the incentives did is it made the contractor think outside of the box in regards to what other materials or what types of operations can they do to maximize it, and then also find efficiency to their operations. So let's get specific into taking those concepts from, a devastating disaster and utilizing it in everyday operations. So they applied this to the I-710 corridor. This is a major interstate through Long Beach into LA. It is the gateway to the Port of Long Beach. Port of Long Beach, second largest port in the US, the 20th largest port in the international trade. $180 billion of cargo value go through that port every year. It makes up about 20% of all of the containers that come into this US. A lot of it's going out on rail, but as you know, rail does very well for long haul, but for those shorter hauls or those intermediate hauls, everything is going out on trucks, and they all go out this I-710 corridor. high truck. That's probably the big one. Is you have your overall traffic may not be that bad, but when you have the bulk of your your vehicles traveling in that route are trucks, it's really going to hammer this road. So let's look at what their strategies that they employed to make this happen. 55-hour weekend closures. They looked at, during those 55-hour, it was going to be continuous operations. They're going to have the entire road from 10 p.m. Friday night until 5 a.m. in the morning. They also employed counterflow traffic, so that in the portion of the divided interstate where they could have counterflow traffic to help keep that route partially open during construction, but that traffic doesn't impede the work that's happening within the construction zone itself. Incentives, disincentives, looking at, can they reduce the number of total weekend closures by being more efficient during their existing weekend closures? They identify, so if they have less than 10 weekend closures, the incentive would be a $100,000 incentive per weekend to keep it less than 10. And then the other way too is the disincentive if they take more than that. You also have to look at the structural design, and in this case taking account with mechanistic empirical design methodologies, new materials, new design philosophies that shrink up the section. What does that happen when we have a smaller structural section? Less material that we have to haul to the job site, less material that we have to put down. That helps with speed of construction. And then also traffic zone, work zone, traffic controls, making sure we have a very comprehensive management plan for both the contractor construction operations as well as the traveling public and those folks who are going to need to use these. So this is what that portion of the interstate looked like prior to construction. 45 years, Portland cement concrete pavement. As you can see, it's seen better days. So at this point, we start to look at what's that design. Let's start with the design and thinning it up. And for most of you that are all of you in here are very familiar with moving towards a long life, perpetual pavement design, and that's really what was employed here. So taking advantage of the latest in understanding of design and in materials and being able to reduce our sections, become more efficient there. You're looking at about a 30-year design with based off of 250 million easels. This is what the two different structural design sections were employed in this project. You can see what the original, existing pavement looked like. You have a crack seat and overlay, and that's pretty much the bulk of the paving that was done. That full depth asphalt was for the sections under the overcrossings, because what they wanted to do is pull all that material off so they can drop the section of pavement down to increase their bridge clearances. So looking at stage construction, you have those crack seat and overlay areas which are in the purple, and you have the red, which is your full depth. So thinking about how are we going to build this with our stage construction? Some of it we're going to go ahead and use full directional closures. Some of it we may use some other types of closures. And then we also have to take into account that when we're doing those closures, we're going to utilize, we're going to have concurrent operations in these areas. This is what helps with speed, is you're not going to do one operation at a time. You'll do multiple at the same time in the same shift. Demolition, any type of base buildup that we need to do, and then finally your paving operations. Safety, we mentioned safety earlier. That's an important thing that we need to take into account. So in this case, they employed a movable safety barrier where they could go ahead and keep divided traffic, as you can see here. So in the pavement that's on the left, what do we see? Full construction of that entire side of the road But then on the other side of the divided, we have counterflow traffic with the movable barrier in between. And then when things are done with, when the construction is done on the left-hand side, they can move that movable barrier to the median, and then they have full access to those, to the other side, the other lanes. And what is that concurrent operations? Every major operation gets its own access lane. This is probably one of the big lessons learned, is making sure that not just having the closure and the place where they're going to work, but have enough space outside of that area so that they can maneuver, especially with different operations, with different types of equipment, maneuver vehicles, trucks in and out, and the equipment, and have enough space to move efficiently and effective. And as you can see down there on the bottom, here's one where we have a full closure, counterflow. So full closure for the 4 lanes that they're completely reconstructing, working in 2 lanes at a time over there on the right-hand side. And what are we looking at? Look at the progress that they're making for both the demo and then the base construction and also the paving. So now when we look at half or partial closure, where you're going to keep one side full just as if nothing happened, but you're going to shrink up the right-hand side for through traffic, and only have 2 lanes to do all of your work in. As you can see in the productivity for that, you still do quite a bit, but it's not nearly as much as when we had the full closure. That's where the advantage of doing a full closure, you can start to see that. And then efficiency through experience. This is just the learning. This goes back to John's current comment earlier, where, you know, if you only do this every now and then, maybe once in a blue moon or very irregularly, what's going to happen? You're not going to have the opportunity to learn and to improve upon that. And so each project you have to start, you want to take advantage of that experience over time. And so here is just getting to understand what that demolition process looks like. That was probably the biggest one in these closures, and figuring out that ballet of moving the different operations and the equipment through the work zone to move as efficiently and quickly as possible. We started to talk about earlier about technology and software, and this was about the time they were actually using some of these Caltrans projects to validate the formulas in the multi-cool program. So this became a temperature management tool. One of the great things about this is, especially as we know with temperature and asphalt mix, when you're in a full closure 55-hour operation, you're paving in the morning, noon, and night. And as we know, the temperatures will definitely change. We need to be on top of what that looks like and what effect that's going to have on the paving operations. So understanding what the time to compact is of mixes and will help us understand how much material we can actually get down during this long shift. So let's take advantage of these types of software so that we can be more efficient in forecasting how much are we actually going to get done in these 55 hours. Because one of the big things is, the big hammer here is a disincentive if it's not open, if the road is not open in time. But of course, with every good project, no matter how much planning you do, there's always going to be something that goes wrong. And how are you going to prepare? How do you prepare yourself to handle that? And in this case, during the full depth reconstructed areas, they ran into some very wet, expansive clays that when they started to pull the slabs out, well, the clay came out as well too, puffed up. So this was during one of their 55-hour closures, so they had time to figure out what the heck happened, how are they going to address it, because this is the first of many of these. So it gave them, while they didn't get their productivity down for that first 55-hour closure, they learned a lot in regards to how to address this in their future closures. And so it's making sure that you have a contingency plan, whether it's traffic, whether it's material production, or whether it's construction activities. You might have accidents and all of these things. You have to be ready for those, and how are you going to deal with this? This actually it took them a few hours to figure this out, and then they got up and running fairly quickly, about 3 or 4 hours before they found the solution. Traffic management plan. You know, we think about, all right, with our regular projects, okay, they've got this road that the traffic can go around. But when we have, for this Port of Long Beach, that much traffic, and not only just regular traffic, but heavy truck traffic, we need a much larger way to manage this. So looking at not just within the construction site, which is that nice little green line in there, but we have to look at it throughout the entire region. How do you get heavy trucks? What are their alternatives? What are the other highways that are involved? Also, vehicles. Where are the other vehicles going to go? And you need to look at this from a perspective of not just can the vehicles go in there, but what other construction projects are happening during that same time? You know, is the route that you're going to be sending all this extra traffic down, do they have a major construction project that they're doing? That's something to consider, as well as local streets too. And they have to be involved in this too in regards to what do they have to do, what kind of work they're doing as well. So this gets back to not just what's happening at that, you know, you deal with that traffic right on that specific project construction site, but you also have to look at the regional impacts that it'll have. So to give an idea of what that looks like for this one project, you can see what the before construction traffic was, and then also during construction, and then a nice little overview of what the reduction was. And then the other part that was part of this project was the development and the verification of software, more technology that we can use, those great numbers that can help predict, modeling to predict what's going to happen with all of the traffic. And so based off of the traffic management plan and the simulation, you can see they were pretty close in regards to what the actual looked like. Now, we saw earlier in regards to a timing of the different traffic loadings during the zone. And so here you can see looking at both weekend, weekday, and weekday traffic, what it normally is, and then with the change to the amount of construction work zone capacity, they needed to do something different. So when they looked at when they implemented their entire traffic management program, what did they come up with? They came up with a plan that seems to work pretty well, because that gray line is for their weekend during the actual construction was significantly below their construction work zone capacity. So they were able to address essentially that blue line, because the blue line is what they were trying to mitigate with their plan. Pretty black highway. So what were the key lessons learned? There's a lot of these here that they learned from this project, and that they now have started to utilize in their current large-scale projects. Mandatory pre-bid conference. This is huge. This is important. This is part of that communication, is before a contractor even looks at this, before they even bid on it and put a number, they need to make sure that they know exactly what they're dealing with, both the pluses and the minuses. Also, it gives the last chance for the owner to get feedback in regards to what's going on. Is there something that they missed that the contractor may have found as they start to look through the actual plans and specs? That's where a pre-bid conference comes into play. Improved performance testing time requirements. John mentioned this. We have these incredible tests that are available to us to tell us so many different components and characteristics of the materials and the mixes that are produced. But if we can't get those results in a timely manner so that we can make proper adjustments during construction, they're not going to help us that much. So that's what we need to, in this case, some of the performance testing that we're done, we're taking multiple weeks to do. Is there a way that we can even shrink that down? Project closures. I think that's something that we need to keep in mind, because it's great to have these 55-hour closures with all these great multiple operations happening, but let's look at this from a personnel, from a resource standpoint for the actual people doing the work. they can only work so many hours in a day, and we're talking about a 55-hour on a weekend. More than likely, these are going to be the A team for the pavers and the construction guys. That means they're not going to have them available for work during the week. And if they do, you're gonna just wear down the workforce. So we need to keep that in mind, and that's why one of the practices that they said is, look, we don't want to do more than 3 to 5 successive closures, because we need to have some breaks in between to make sure that the resources, the people out there, have a time to sort of sit back, recharge, and then get back into the high-intensity work. Because that's the one thing about these work zones. They become very high-intensity. Also, contractor getting involved in regards to closure, locations, meteorologist input goes back to weather. Not just what's happening morning, noon, and night, but also long-term. Because the last thing you want to do is have a 55-hour closure, then a rainstorm comes through, and you're not prepared for that. So you got to keep planning. And I know up in the northern part of the state, especially with some of the bridge work that's been done, they've been promoting out 55-hour closure, but then the weather was going to change, and they ended up stopping it. And so that's something that need to always keep that. And then contingency, which I mentioned already, is we need to make sure that we are prepared and ready just in case something doesn't go right, and something will not go right. Just be ready to react to it and have the flexibility. I will say this, there is a UCPRC document that really contains all of the summary of all of these lessons learned. Finally, to get through the construction aspects of it, of the lessons learned, hey, we having these closures, the more closures you have, there's a learning process. We increase productivity over time. Monetary incentives actually do work for early completion. And then dealing with incentive, disincentive pay factors for material quality, that helps to make sure that we get the high-performing pavements that we need. Now, for those of you who are really curious, this I-710 project that was done to date, it is performing just as anticipated. In fact, they just had their first, it was made to have a sacrificial wear layer that for the first phase was removed and replaced, new wearing surface on it just within the past couple of years. So very good, successful project all the way around. And then we'll also talk about the technology and the software. Multi-Cool, Rapid Rehab, that's the software that was developed by UCPRC to really help take in all of those components of construction, the economic factors, everything into it, and then and your transportation plan, and go ahead and put that out, evaluate different types of scenarios to figure out what's best for the project. So we've seen Caltrans implement this on multiple projects throughout the state. You know, you can tell that there's a media component to it because all of these have their fancy logos just for the project itself. And in fact, you'll have, a lot of them have their own web page with all of the particulars from a communication standpoint in regards to what's there, how people can figure out what the alternate routes are, scheduling. And communication is key. So we look at what are the different types of communication that the state is focused on, communicate with all of these key stakeholders. It's important that there's always going back and forth, regardless of the type of project that we're looking at. So some of the traffic management things to consider is contractor staging, where they're going to put all their stuff prior to or during construction. We need to account for the incentives in the project budget. These are some of the things to consider. Coordinate, here's the big one. Here's really the two big ones for traffic. Coordinate traffic plan with the local governments. If you're going to end up putting more traffic on local streets, they need to figure out, can their streets handle it, number one. Number two, is there something that they can do on those streets to help move traffic flow a lot easier? They may have to change their signalization. They may have to change their striping on their roads. Also, what effect does that have on transit? Do we now have light rail cars? Do we have to add more cars because we anticipate more people on the light rail, or buses and bus routing through the areas? And also especially emergency service access. If something happens, an emergency in or around where vehicles need to go through that area, how are they going to get through? And then also the business side of things, especially in California with all of the traffic that we have. If you're going to take out a major interstate area, major commuter route, how can the businesses help? Flex schedules, telecommuting, other types of commute alternatives. That's going to help to relieve the traffic loading in those construction areas. Also, hour-by-hour scheduling, having that central traffic command during those operations, people who are constantly looking at what's happening with the traffic so that they can react either with something to do with the actual construction operations or bigger picture in regards to regional. Always looking ahead, keeping everyone. And then also the media. We all have to remember media, especially in this case, is our friend. And the other part is get them to scare the heck out of everybody so they stay away. And we saw that with Carmageddon and great. They called it Carmageddon, I-405 closure in LA, and they scared everyone so much that they had a huge reduction in overall regional transportation. So that's something to keep in mind. But no matter whether you're able to do that and how effective you are, something's always happen. And so in this case in Sacramento for the Fix 50 project, which is a major highway through the center of the city of Sacramento, they let all the media know. So what did the media do first thing in the morning? Let's send up our helicopters. We'll go hover over the construction sites, and we'll let everyone know what's happening with the traffic and the construction. Well, all of the neighbors, and just so this is a neighborhood that I live in, you hear the helicopters, all of the neighbors started complaining to their local representatives about all the helicopter noise. So then that goes back to communication. Had to reach out to the different media folks and say, hey, can you guys find a way to share video because we don't need 3 helicopters over the same site, 1 will be enough, and try to make that a little bit later and not so early. Communication. Always remember that we need to keep in mind of not just regional, but keep in mind all of those homes and businesses that are right next to our project and keeping them in the loop as well, directly, right? So we need to keep that in mind as well. So with that, Adam, I'll just say if there's any technical questions related to clarifications, I'd be happy to take that now. Great, thank you.
Thank you, Brandon. We trying to get back to our schedule here. We're scheduled to take a break now, so we'll take a break for about 15 minutes, and when we come back in, what we want to do is get 7 groups established. And so if we break the room up and we have group 1 at the first couple tables in this section, group 2 in the back couple rows, 3 here, 4 there. I'll repeat this as we come back in. 5 and 6 here, and 7 and 8 there. That would be fantastic. You will on your way out or your way back in will be given a number, okay? If you don't have one already. And again, we appreciate your patience this morning with our technical challenge, or this afternoon with our technical challenges, and we'll look forward to you coming back in about 15 minutes to get the workshop started. Thank you.
go and check over there, sir, and see? Or no, it's just a straight run over here, I think. It's a 200-foot run. Let me try one more thing. Come on, man. Why would I not be doing that, though?
Try plugging the laptop straight into the switcher.
Still nothing? Dude, what is going on, yo? Alright, stay right here. Stay right here.
we going to come up here after the breakouts?
Yeah. They're supposed to.
They rang a bell.
Oh, so are we ready to go?
I heard a bell ring.
If we could get everybody to come on back inside. And depending on your number, that hopefully everybody has a number, and between 1 and 7. And again, what we would like to do is get folks in group 1 huddled in the first couple of rows over here in the first, first column, the chairs. And then group 2 in the back part of that section. Group 3 in the front part of this section, and group 4 in the back couple of rows. 5 in the front section here, 6 in the back section there, and then 7 in the front section there. And the idea here is to talk about, amongst your groups, talk about what was just presented, or think about what was just presented in terms of context, and then identify things that we're going to have to do as an industry to respond to the changes that are going to take place. And what our goal is to get a list of items relative to planning, materials, pavement design, pavement construction operations, quality control and acceptance, the workforce, and economic analysis, and a top 3 to 5 items within that list in about 30 minutes. So again, there should be a new member with each group facilitating the conversation and taking notes. And is there a new member with each group? We got group 1 over here, group 2. Hey, how about group 3? We got a new member. Group 4. Okay, great. 5. Great. 6. Okay, a bunch of you. Okay, and 7. And maybe if we could get you to sort of huddle together a little closer. I know this room isn't set up ideal for this type of conversation, but sort of flipping rows that are back to back to facing each other, I think would be helpful. Again, we'll give it about 25, 30 minutes, and then we'll have a report out and a panel discussion. Thank you. Phil just shared with me that the streaming is working, and there's even somebody in Poland, I think he said, watching. So for the folks online, we'll be in our groups for about another 25 minutes before coming back for the summary and report out. Okay, so group 1, 2, 3, 4, 5. Group 5, you'd be QC and acceptance, right? It's different. It is. It's number 7. Okay, there's. I understand that the groups that are on the screen and the pieces of paper that you have in front of you are not consistent. So let's leave the groups that are up there just like they are, and we'll get the papers for notes to the right groups. All right. It's great to see all the lively conversation taking place, and that's really what workshops are about. We need to go ahead and wrap up our conversations and highlight the top 3 to 5 items on the list, and have a group discussion about those items. So I'm going to ask that the presenters please come on back up front, and the new members pass the summaries back up. We'll give it a minute to get organized here. Group 1 has already provided it, so we can get rolling.
We must be pavement experts.
Turn it off. Now it's live.
I guess there's only one mic.
That's fine. Oh, wait. Maybe we should sit on one
Probably,
side.
yeah, probably ought to. This is live.
It's live now.
Okay, if the leader of each group could come on up, the new member leader from each group. All right, we're going to go ahead and get started, and the new members are going to come up, and what they're going to do is share with us the top 3 to 5 items that were identified in their individual groups. And then we'll have an open discussion with our panel up here. And we'll go ahead and get started with planning.
Afternoon. My name is Adam Taylor with NCAT. My breakout group was on planning as related to speed of construction. The most common topics were mainly about contractor involvement, especially in the pre-bid stage, how to best get the contractors involved to maximize the speed of construction and ease of the project. Topics related to that, related to mainly logistics, lay down yards, how contractors could maximize their resources pre-bid, as well as clear communication between the agency and the contractor between how conflicts would be resolved during the process of the job or the course of the job. Another topic related to planning was maximizing use of in-place materials to improve logistics. We talked about different materials engineering topics that would improve, that would assist in the planning process by improving logistics, namely cold in place materials, lime stabilization, rubblization, things of that nature. And then finally discussing traffic design, how the agency would best understand the impact of closures and the traffic patterns where these jobs are going to take place. All right, next up.
I'm David Ferris. I was in charge of the materials group. Some of the stuff, well, we got started talking about several different things, and we ended up talking about a lot of different things that's probably covered by all these groups. We realized how interconnected all of these different topics are when it comes to speed of construction. But some of the main points we walked away with is standardization of material performance specifications on maybe a regional level, kind of expanding further than the state level, might help out with the speed of construction. Better evaluation and rectification practices for subgrade materials. There could be some improvement there. We didn't get into specifics, but we did talk about how foreknowledge, better evaluation from the agency standpoint before the contractor gets into a job and finds clay like we saw earlier or something of the sort could help out the speed of construction and better planning. Further research into go, no-go indexes or QC practices. Again, kind of crossing the border there, but also has to do a lot with the materials, as well as increased utilization of full depth reclamation or cold in place recycling as base materials could help improve the speed of construction. So those were kind of the main points we touched on.
Good afternoon, everyone. My name is Khalid Hasiba, and my group was responsible for pavement design. We discussed how pavement design can influence accelerated construction. Like what David mentioned, topics are interrelated, and this topic can intersect with material testing. So if more testing is performed ahead of time and making sure that this data, soil data, and material properties are available easily and fastly to the designers, that's something that will definitely accelerate the pavement design. Another thing is removing conservatism, which will make pavement design more economical and appropriate for the existing needs. Finally, advocating perpetual pavement as one of the options. This will allow the agencies to only worry about the surface material and not worry at all about the lower layers. Thank you.
My name is Raquel. We are the group regarding paving construction operations and equipment. So the group highlight 4 main topics. First, high production placement rate. The 2 main observations were the more equipment is necessary and that improvement of the specifications could also be achieved. Regarding rapid testing, research, implementation, and training were the 3 main points in order to have better testings in the field. Regarding quick feedback to produce quality, the main topic were improve up communication, research in order to implement the new technologies that exist, and implementation of ways of collecting results in a real time. Regarding the management to ensure quality of data, main suggestions were to work together with the users producers group in order to analyze the data collected per state, in order to see what are the main defaults of the specifications, which testings are getting more negative results. Thank you.
Good afternoon. I'm Dave Van Duzen with the Minnesota DOT, and our group was QC and acceptance. And right out of the gate, incentives and disincentives came up, and had discussion on that, and made a note that specifications, the typical owner specifications can't be maybe not used effectively on a expedited job. So you can't just recycle the same specs, testing rates. In fact, they're not set up at all for allowing the communication between the different layers of the team. And New Zealand gave a good example in their accelerated projects. Once the contracting entity is selected, then they kind of form a small company or an alliance with the owner agency to facilitate better communication, which is really crucial, especially earlier on in quality control. And that was another item that we talked about, that the old standardized test methods may not be the most effective. We need research or maybe even implementation of existing research products to get newer technologies for quicker testing into the business. Performance testing was also mentioned, relying less on proctor tests and so forth for soil. In fact, going to intelligent compaction or other types of proof testing, proof rollers that we use in my home state, basically an end performance product type test. And we also talked about pre-acceptance of contractors, and the arguments there, the contractors are concerned, is it really fair? Is it based on sound expectations? And from the agency standpoint, they don't want to get sued. I think every state that's had that experience, there's always somebody that's very happy and others that are very, very upset. New technologies, we did make a list. In Minnesota, we're using a GPR-based dielectric proxy for in-place density on hot mix asphalt. There's laser devices for determining aggregate particle size during production. And basically we need advances in testing technology, quicker tests and turnaround, and better communication. And then lastly, I wrote down low bid model may hurt expedited construction. I guess that There's nothing truer than that, but it's very hard to get away from. Thank you.
Hello, everybody. My name is Deborati Ghosh, and I'm with MinDOT. So my group was, what does speed of construction mean to the asphalt industry, and how it should need to respond in terms of workforce. So based on the discussion, what came up that we need more workers. We need to ensure that they are not very tired and that we are compromising the quality of work. So we should increase shifts, but in order to do that, getting some more worker is challenging. So there might come some automation we can introduce too, which is like very mainstream work. We can use some automation in there so that it can reduce a little bit of workforce. Also, lack of training is sometimes a very big issue, and lack of basic knowledge. So we can use technology and give some online training so that they can know beforehand like what they're expecting on what they're supposed to do. And also in terms of like acknowledgement, sometimes I felt like there are some gap between the engineers and the workers. And since if there is some bad quality work in the construction, we can't see it like right away. So sometimes we think like, okay, just we will deal with it later on. So maybe if we acknowledge them more, they will be more dedicated what they're doing. So basically lack of training is, so we have to ensure more training and then higher wages and more shifts so that we can ensure a very successful integrated workforce system to ensure a very efficient pavement system. That's all. Thank you.
Good afternoon, everyone. My name is Amir Kolalipur. Our group was discussing about economic analysis, and it was very interesting to see that how very different topic and discussion got into economic impact on the projects. We talked about the user cost. We talked about agency budget limitation that is always a factor in projects. We talked about incentive, contract mechanism, importance of the location of the paving project. For example, if you have a project in the heart of Manhattan, is it going to be the same impact as if you have a project in a rural area in New York? Is not. So we discussed about very different type of basically items that they can impact the economic analysis of the project. The main three items that we conclude is important. One of them is new materials and innovations. Again, this is what we can do as asphalt industry to have a positive impact on economical aspect of the project. So new materials and innovation is always something that we can contribute. Another one was non-traditional type of contract, how we can basically introduce incentive and basically different type of delivery to the project. And also we have some feedback from design team and contractors built into basically to the contract. A note should be mentioned here that this is not always appropriate for any project. So you need to also look at the nature of the project. And the last item, but not the least, was about education, about the models. Like Jeff presented about those economical models and how different factors can basically impact the results. But some of us in this room, we haven't had that much exposure to those models. So education on those models and how those software they work, it can provide a good tool for us that we can contribute on this topic. Thank you.
I'd like to thank the new members for helping out this afternoon and reporting out what the observations from the groups were, and all of you for providing your input. We've got about 15 minutes to have some sort of open mic time. There are mics in each of the 2 rows, and if you want to come to the mic, please come up and state your name and affiliation, and then we have our panel here that can hopefully answer whatever questions or respond to whatever thoughts you might have. We'd like to go ahead and open it up. You gave them all the information, guys. I was going to bear a minute. Okay, go ahead. Go ahead, John.
What does the accelerated construction mean to the asphalt industry? That was one of the questions you posed out there, and we sort of talked around it, but we never really got there. So is this, I'm thinking as a marketer now, and something that will move the industry forward, give us a better market. Maybe we shouldn't go there in these kind of meetings, but we are for a minute. What does asphalt paving, asphalt bound mixtures in general, do they have an advantage in this accelerated construction arena? Maybe somebody would like to address that from the audience or one of the other panelists.
All right. Okay, so I would say absolutely it has a huge, asphalt has a huge impact in this, because we know how quickly contractors can place material, asphalt pavement, and immediately open it up to traffic. It's a cooling effect, and that's what we're waiting for, is for the mix to cool, build the cohesion, you're ready to throw traffic on it. That's really important from our industries when we look at how do we market against the other type of pavement choices. And when we look at that, whether it's concrete or asphalt, time of construction is huge. And not only that, but now not only do we have the advantage of time of construction, but within the new design methodologies, the continual improvement of the materials that we can utilize, the ability to utilize existing materials, whether it's through in-place recycling or utilizing it as wrap into a portion of our new mixes, we're able to have something that's cost effective, but also something that will perform under some of the most challenging conditions that we face, whether it's environmental challenges or, more importantly, that we see around here, traffic loading challenges.
Does anybody from the audience want to provide any input on that? If not, then I think Mr. Gallivan has something to share with us.
Guilty as charged. I appreciate all 3 of the presenters. You gave great information. One consistent information, one piece of the puzzle was communication. All 3 of you mentioned the importance of communication, and our new members from each of the section. I think 6 out of the 8 talked about communication as well. So what are we, the industry, doing to communicate the importance of this process and what it can do? Yes, we have a few meetings at AAPT, we have a few meetings at TRB, we have a few meetings here and there. But what are we doing if we need to get the message out to communicate the process and to communicate the necessity to how to make this thing move forward? Oh, Lee Gallivan, consultant. I'm sorry.
You want to take that one? Anybody want to take that one? I think Lee's posing the question to the audience and the panel. Go ahead.
Yeah, that's the $1 million question. I wrote that down as everybody was talking as my big thing. And I think it keeps coming back to the bid process of how we keep talking about minimizing the cost for the project. And that's the be-all, end-all. And then there's all these other components that factor into it too. And we need to think beyond just that first number and be able to communicate that there's all these other things that you need to worry about at the same time. I guess that's us that are working on these projects and communicating with the DOTs about it, but I don't think it's going to be a quick solution It's going to take time to make that happen.
Say a normal paving product takes 10 things to have right to make it go well. It's just a number I've selected. And just looking at accelerated construction, it may be 100 things that have to be lined up properly for everything to work smoothly, all the way from the planning phase of it, where the economics come in, select the right project, et cetera. And in my opinion, the reconstruction or rehabilitation, major rehabilitation in urban areas, the economics line up really good on that. It's flashy, it shows, and it makes a great case study for the newspapers and the media, et cetera. And it's very, very important to do that. But there's a lot of rural areas where you can do some things that really take a county and make it your biggest proponent for your construction operations that might weigh heavily on the State House. And I think it's important not to forget about those jobs. The state highway through a town of 10,000 that has stores that one or two county ranchers, farmers use, and to keep that project under cones for a number of months is not acceptable, because you'll force a lot of those people out of business. So if a state or other county governments can figure out ways to accelerate that, and you can fairly easily, they're huge winners from a public relations, public information point of view. And I think a lot of this is technology is going to help us, but the integration of all of these things together is just a very difficult thing to do. And I think we just haven't concentrated on putting everything together piece by piece to make it a nice package for us.
Jim Schrockman, consulting engineer. Two things we need to look at. Number one is education on both sides, both the agency side and the contractor side, because it's tough to go talk to somebody about changing designs or criteria for something when you're talking to people that don't know what you're talking about. And when you get people in highway departments that they used to be the right-of-way engineer and they're now the state materials engineer, and those type of things, it's very difficult to hold a worthwhile conversation. The second comment I'd make is we need to get this industry to warranties so that we end up being responsible for what we're doing as a contractor, and that we have some input then into the design process and some leg up in the performance of the pavement. But I think those two things are the things that we need to concentrate on, is how do we educate our customers to tell us what we're supposed to do and actually be able to do it as a contractor. And number two, I think we need to be responsible via warranties for what we're doing.
Anybody on the panel want to respond to that?
Jim, I agree with you on the warranty part of it. It's, as you well know, it's very unpopular in many public agencies and states these days. I think if we can accelerate construction and warranty it at some level, and ask the contractor to become very involved in that process, because they would be if they warranty it, it would probably move it faster forward than anything else we could do. I don't know that there's a lot of public will to do that right now, but I would agree with you wholeheartedly that we need big changes in some of those contracting procedure specifications, how we do business.
I guess I would agree with the education piece as well. When it comes to transportation planning, at the Metropolitan Planning Organization level, a lot of consultants will come in and do projects and teach the local governments, municipalities, how these things work, to then help them understand why they're doing things later on down the road. And if there's a way for that to kind of translate over into this field too, that might be a nice way to extend that education for sure.
And I think one thing on the training and education that we have to keep in mind is that training and education is a continual process. Just because someone has attended one class doesn't mean they've got it all. They've got to pair it with their experience. And I've had it where I've been in one class, You know, we have these training classes all over the country, and I've gone once, and then I go back again a couple years later, and because of my experience, that whole training class I have a different perspective on what they're saying, and I may pull something else out of it. So I think if we're going to have that training, it's not just because someone is new to the position or new to the industry. It has to be something that we commit to do continually. Even if we've heard it before, it doesn't hurt to hear it again, because sometimes through all of our experiences, we end up maybe cutting a corner here or there, or we forget what the true importance is, and we need to keep that training and make it a continual effort.
My name is Brandon Braver. I'm with the Minnesota Asphalt Pavement Association. I just had a comment, and I don't know if this was covered. I might have missed it, but one component maybe from the contractor side is the safety aspect of this, accelerated construction. It's a good testament to our product that we can do all these fixes under traffic, but there's also that component of it in that if you're doing night work, or that you need to be able to do this safely, and so you kind of need to balance it a little bit as well, so that you're keeping that in mind. So something I just wanted to hit on.
Yeah, the safety is very important, and it becomes even, we think that we have a 55-hour closure that all of a sudden we've taken the traffic out and we have a much safer environment. Well, actually, the risk is probably higher because now we've got multiple operations happening at the same time in the same space, and that could be even more problematic. And we do need to keep in mind from a traffic flow standpoint, but even from a construction standpoint, what the risks are from a safety perspective, and we have to make sure we are planned to make sure we have a safe environment and everyone understands what everyone else is doing, not just what you're doing, but what someone else is doing, so that they'll stay out of your way and you can stay out of their way. That is something very important for us to keep in mind in all of this.
Any other thoughts before we wrap it up? Luis, are you headed for a mic, or are you headed out the door? Like he's headed out the door. All right. Well, again, I'd like to thank everybody for taking the time on Sunday afternoon to be here, and thank our panel of experts who provided some great presentations, as well as all of your input in the breakout groups and the young members or new members that help facilitate that. What I will do is I will take the notes from each group and summarize them, and just like the preprints have been posted for the papers, I'll have a summary of the output from the groups that will be posted on the website. And I have to make a couple of announcements here along the way. One is that at 5:30 to 7:30, the poster session and the icebreaker reception will be taking place out on the River Terrace, which is on the 3rd floor. And if you go down to the escalator here and go up one floor, it's just go. I'm disoriented. Parallel to the river, that direction. You'll be able to get out the door to the Terrace River. Okay, follow the arrows that say AAPT is what the local arrangements folks have to say. The other thing is that if you've not registered and you want to get registered before tomorrow morning, they've moved the registration desk out to that area also, so you can get registered while you're out there. And with that, again, I'll thank you all for your time this afternoon, your participation, as well as the folks online. Phil told me that we still have over a dozen folks on our streaming experiment. So thank you to you folks also. I'll have a great evening. Thank you.